All right, so shall we chat about science then?
Sure. We should have planned this. We should have planned this out instead of screwing around.
No, that's all right. I mean,
story of my life.
One of the things, that I hear in podcasts all the time is like, oh, we'll cut this out later. And of course, I hear it in the podcast and you're like, oh, well, clearly they didn't. And I can never tell if it's a running joke that they'll cut it out or if they actually just got lazy and didn't cut it out. But I guess we can find out now whether or not we're going to do it that way. Anyway, so shall we cast some pod?
Sure.
I'm also figuring, the analogy in my head I was using for this, you know how the first few episodes of something are always kind of crappy and like not like the final versions, right?
Yes.
Have you ever seen like the old Garfield, like the first few strips of Garfield where Garfield looked like a big sack of potatoes with eyes stuck onto it and, was wholly unappealing as a character? I figured this would be like our episode of that. And where John has like the weird roommate with the mustache that looks like it's made of flesh and he kind of looks like a child molester. So I figured this would be like that epised for us. And then,
is that a real thing, or are you taking some serious drugs?
No. Oh, so if you look up the old Garfield strip, his name was Lyman, Lyman. Or look up like Garfield Lyman.
Oh my God.
I think I'm remembering this right.
You are.
Kind of terrifying
it looks kind of like it's like John from the neck down and Frankenstein above that.
Yeah, and if you look at the first, or if you Google image search like first Garfield strip or something like that, I imagine it will work. Like Garfield is horrifying looking and not at all lovable.
I'm looking at one of the first ones, which has been dubbed, I guess, into Mandarin.
I'm not sure. I'm pretty sure the first Garfield strip was not actually in Mandarin. That's the one where Johnny eats Garfield in the strip, right?
Actually, you laugh, but yes, it is. Here, I'll send it to you.
Is it? I saw somewhere. I can't remember where it was. I think there was a strip where it was implied that Odie was eaten by John at some point. But so anyway, welcome to our podcast, Internet Strangers.
All right, should we try this for the 17th time?
But no. I mean, I think there's good stuff in here that we can probably use. But anyway, this is, I think, our our weird roommate with the mustache that looks like skin, child molester episode of the podcast, and then it'll probably take final form later, I would assume.
I hope so.
So shall we introduce ourselves?
Yeah. Go ahead.
You want to start? Well, no, I was going to say you can start because I've been chatting more.
So I'm Matt Krause. I don't know what to say here.
I don't know. We're both neuroscientists. We're starting a podcast about science to share our witticisms with the world.
So far, we've successfully talked for 90 minutes without actually getting to any science. But
it's true, and 11 minutes that are actually recorded. Or no, 20 minutes that are actually recorded. But we've occasionally dipped into science so far.
It happens from time to time.
Yeah. So I guess we could sort of say that, so we know each other from grad school, which we both semi-recently completed, PhD-wise, not like fake grad school, like, well, I won't name any names, but
zing.
We both graduated from the University of Phoenix together.
It's true, we met in a chat room, exchanged cat images.
Then, both of us found out that we were actually dudes, and here we are.
We're actually both FBI agents.
Yes. It was awkward. So, well, I don't know how much of our real identities we want to give away, but we both went to a relatively prestigious, I suppose. Somehow we got into a fairly decent grad school despite our slackerdom.
Yes. Thank you, clerical oversight that allowed us in.
Yes. I seem to have swapped some decimal points in that GPA calculation, but here we go. But now you're a postdoc, and I'm an assistant professor, and we are both strangers in strange lands, actually living in different hemispheres, but podcasting away nonetheless, huh?
Yeah, I think actually, are you still directly across the Earth from me?
Well, so, because I'm on the equator, right? So If you look at if you go to, did we already talk about Antipode? I think it's called antipodemap.com.
Yes, we did.
Or
we did. But I thought you were surprisingly close to.
Well, I don't know if you know, but Canada's not actually on the equator.
Really? You would never know from our warm, sunny weather.
No, but so if you, what is it called?
Antipode
map.
Oh,
Is it just antipode.com?
I went to freemaptools.com. Oh, you're right.
Oh, there used to be one that was called like antipodemap.com or something, but maybe it got taken off because I see the free map tools. Anyway, if you put in my my location,
You come out somewhere in Colombia.
yeah, something like that. But if you go up to if you sort of just go up in latitude, you can do this with Google. Well, I guess it uses Google Maps, right? You can do this in Google Maps too, just by finding your latitude and longitude and then adding 180 degrees to your longitude, I guess. But if you go up until like you hit the U.S., I'm 180 degrees around the world from like Durham, North Carolina. So
that's kind of crazy.
Yeah. So if you go 180 degrees around the world from where like my parents live in North Carolina, you would end up in like the Indian Ocean, but like due south of me, basically. And yeah, so if you go, looks like if you go due north from Durham, you're somewhere between Toronto and Ottawa. But yeah, still pretty much 180 degrees longitude around the world from each other.
Ironically, if I dig a giant hole, I will end up in Antarctica, where it's also freezing.
Oh, that's interesting. I didn't realize you were actually, Montreal is that far. Well, I guess I've given away your location now, ladies. Are you actually?
Well, no, I end up in the Antarctic Ocean. I'm south of Australia.
I see. Yeah, so you're like right off the southwest tip of Australia. So actually, that's not too far because if I pinpoint myself on this, this one actually works a fair bit better because you can see them both in like stereo than the other Antipode map site. If I zoom in on Kuala Lumpur, I mean, I did this once like down to like the actual location of my house, but I guess it doesn't matter. Well, it only matters insofar as it's right on the Ecuador and Peru border, I guess. But so I'm right directly across the world from like the southeast-ish portion of Ecuador.
Clearly, the only reason you have not dug a giant tunnel through the earth is you don't know which visa to get once you arrive.
Yes, actually. Well, you know that this is actually science related. I would really love, I mean, this would be impractical to do, but I would love somebody to do the actual experiment where you you bore a hole directly through the earth and jump in at one side. And, in theory, except for air resistance, you would pop out exactly on the other side, right?
Yes, and do you know that the transit time, this is amazing, and I'm not sure if it's true.
No, what is it?
42 minutes.
Really?
I've heard that, and it's so good that I have not bothered trying to figure it out myself or verify it in any way, but yes.
That's the best kind of science, I find. So have you ever done the calculation? I'm sure this is answered somewhere on the internet. Have you ever seen anyone do the calculation as to like how close you get if you factor in like air resistance and so forth?
No. I mean,
we can look that up.
I assume you would die a flaming death at some point, like fairly rapidly.
Yeah, I mean, you have a certain liquid hot magma factor to overcome, I suppose.
Well, I think even if even before you get to the molten core of the Earth, it gets pretty friggin' hot.
Yeah. Well, I mean, and even if I suspect that this is one of those spherical cow situations where there are so many hypotheticals and things we're going to have to gloss over that it's not really a useful question anymore. But like, if you had like a smooth tunnel all the way through the Earth, a tunnel holding back the magma. Okay. But that would still heat the air significantly. I'm just trying to think like how that would impact things like, if you did have air flowing in from the atmosphere here, let's say you built just dug like a 6 foot wide tunnel, just enough for like a human being to comfortably like jump through.
Are you a 6 foot wide human being?
Well, you got to have some room for like your arms to stretch out a bit and stuff, but
Yeah, okay.
Okay, but in other words, like not a mile wide, like, a few feet wide, and you're sort of encased it in aluminum or some kind of metal or something to hold back the liquid hot magma, some kind of reinforced metal or something. But then you obviously still have like you'd have airflow in then from the atmosphere that would permeate the core, but that air would be very hot.
Well, wouldn't that air be going the other way? Wouldn't it be going out from the hot towards the cold?
Well, I guess not. I'm just saying that when you dug the hole in the first place, air from the atmosphere would go into the hole.
Oh, yeah, for sure. As it does.
Then you would have some kind of equilibrium state. But because there's no air in the middle of the Earth at the moment because it's filled with dirt and magma. But I'm not sure how much you know about geology.
Tell me more, Professor Johnson.
Oh, I will. But anyway, yeah, so I just wonder what that would do if you had I'm actually not entirely sure what the heat is at the Earth's center. I'm sure we could look it up very easily. But, then you'd have some sort of impractically hot air, which would, I guess it would make the air very thin, right? Because it would all be pushing to get out.
Yeah, I actually wonder if you would.
So actually, maybe you wouldn't have much of an atmosphere at the center.
So according to phys.org, which is reasonably reputable, the very center, it is believed that temperatures exceed 11,000 degrees Fahrenheit, hotter than the surface of the sun. That's quite hot.
That is hot.
And apparently there's all sorts of reasons it's hot. There's some heat from crushing. There's some heat from it just being hot, like left over from when the planet condensed. And the vast majority of the heat is apparently, actually I didn't know this, is from radioactive decay. So you've got radioactive, there's all sorts of uranium, potassium, and thorium.
So I guess the center of the Earth would be pretty highly radioactive if you were to fly through it on your way to, if I were to fly through it on my way to Ecuador or whatever.
Yeah, so apparently you're going to die from 3 or 4 different kinds of burning to death, plus cancer.
Okay, so burning to death plus cancer plus all kinds of other things, but... Shoot, I'm a little quieter now because I'm looking for the joke I made the other day on the internet. Well, the basic thrust of the joke was, here it is. Of course, at temperatures above 10 to the 6th Kelvin, jumpin' jack flash is a plasma, plasma, plasma. So actually, that would work pretty well because you'd be jumping jack, through the center of the Earth flash. Anyway, and you probably would become a plasma. All right, well, so that was a digression, but it was about science.
Yeah, that was actually, I think we should run with this.
All right, cool. So anyway, what's our plan here? So our plan is to do a podcast of some sort, talk about some topical issues in science, I suppose, and not just neuroscience that we do, but other science, because I would say we are fairly well-read.
I think we are Renaissance men in
yes.
Both in the original meaning and our level of scientific expertise.
I was going to say, we are Renaissance men, so we still believe that the planets move in circular orbits, right, around the sun.
Yeah, so the Earth doesn't really have a core, being a flat sheet like a pizza.
Right. Few people know that Galileo was actually an early pizza artist in Italy. He would drop pepperonis off the Leaning Tower of Pizza. Anyway, and yes, that's why the Catholic Church didn't go for that.
Yeah, he dropped the meat on a Friday, which is just absolutely unacceptable.
Yeah, that's too bad.
Had he dropped fish?
I feel like there's a wine and crackers joke that's taking it one too far here, but maybe we'll just leave it at that.
You'll have to tune in a future episode for that one.
Yeah. Anyway, so we'll talk about a couple of current science topics, I suppose, and maybe some general discussion, which you've already seen a little bit of, I suppose. So do we have a news item or two that we wanted to talk about?
You wanted to go with the anti-gravity, I think.
Yeah, I think we were already kind of on a gravity kick, I suppose. So, but we weren't sure, now we have to read the article closer, right? Because
it feels like we're in grad school all over again.
There's the anti-gravity and the dark matter particle article. The particle article.
Yes.
The article particles. Wait, the particle articles. Well, so there's the first direct measurement of gravity's effect on antimatter that we could not actually discern what that was. So I'm not sure. Antihydrogen and free fall. Did you find this article on scinews.com? There might be a better link.
I'm reading the Wikipedia article.
I'm going to look up gravity antihydrogen. Antihydrogen. Because I'm not sure that one source about the antihydrogen is. Is antimatter antigravity from UC Berkeley. That might be better.
Who's the author?
You mean the scientific lead author?
Yeah.
Well, if it's like most physics articles, there's 7,000 people. Everyone who's ever been a janitor at CERN is probably listed. But no, it's people. It's actually 4 UC Berkeley physicists. This is actually the Berkeley press release here. So Joel Fajans. I believe that's Spanish for the Fawns. Fajans.
Fajans.
UC Berkeley professor of physics. So
he looks quite physics professor-y.
Oh, really?
He's got kind of a fro and a beard in his earlier pictures.
Yeah.
Yeah.
He looks a little like Steve Wozniak-ish, kind of.
He definitely looks like a man who would know about gravity.
Yes.
I aspire to look like that someday.
Just keep growing out the beard and having stress.
You laugh, but I don't think I had ever seen a white hair on my head until the day I started writing my thesis.
Oh yeah, I'm a couple years older than you, but the gray hair has multiplied vastly since starting the old faculty job here, which is a little disconcerting.
Is it this nonlinear dynamics of antihydrogen magnostatic traps?
Oh, you're actually looking at an actual publication, huh?
Of course, you gotta go for the guts here. Oh god, it's a physics paper where there are gratuitous equations.
Yeah.
Conclusion?
You said, what did you call it?
It's nonlinear. Here, I'll give you the title. You can get it from Archivix.
I've got description and first application of a new technique to measure the gravitational mass of antihydrogen.
Nope. It's March 13th, 2013. It's nonlinear dynamics of antihydrogen magnetostatic traps. Oh yeah, implications for gravitational measures. The influence of gravity on antihydrogen dynamics and magnetic traps is studied. The advantages and disadvantages of various techniques for measuring the ratio of gravitational mass to the inertial mass of antihydrogen are discussed. Let's back this up a second. What is antihydrogen?
Well,
is it hydrogen made of anti-atoms or antiparticles?
Well, yeah. Antihydrogen would just be antimatter versions of hydrogen, which hydrogen is just a proton, right? So
yeah, so I guess it's just
with an electron. So it would be an antiproton with an anti-electron, I suppose.
That's positron, right?
Yeah, positron. Yes, an E+ in physics notation.
I didn't know you could actually make things like this.
That segues into apparently you can also use tiny little tweezers to make movies with atoms. But
yes, oh god, we should focus at some point.
Focus, focus is for microscopes.
Okay, there's no way I'm going to be able to read this paper while talking.
This, it's funny. The press release says the same thing as the crappy scinews.com article. It's like,
what a coincidence!
Yes, well, though far from definitive, the UC Berkeley experiment points the way towards a definitive answer to the fundamental question of whether matter falls up or down. But yet, they still don't say what the answer is.
Dude, is there a spoiler alert at the bottom, maybe?
I don't know. Apparently, they're bringing back Lost to show this on a future episode.
Okay, so I guess my surprise at this is somewhat okay. So they've only been able to make antihydrogen for about a year.
Oh, really?
Yeah. It's a CERN thing.
So how do you make antihydrogen? Do you
exactly like you said? So you make an antiproton and a positron, and then you smash them together.
Well, I guess it's I've read a fair bit of. I really like. Have you ever read Leon Lederman's book, The God Particle? It's old now because it has it speaks wistfully of the day when the superconducting super collider will be finished in Texas. Sadly. Yes, let's pour one out for our fallen homie.
So that was 20 years ago? 25 years ago?
I think the book was written in 1992, and the project was canceled 2 or 3 years later.
Yeah, the project was canceled in 93, I think.
Yeah. So, But it was a really good book of, like sort of the history of particle physics, actually going back to, when particles meant like, balls dropped off the Leaning Tower of Pisa, or so it is claimed. But I mean, I assume what it actually is, I mean, you have basically, you correct me if I'm wrong, but I'm assuming what you have is you have like particle accelerators that sort of, start off by colliding things that we have in nature, like protons and stuff, and then you catch and save magnetically or however the outputs from those collisions, right? And then if you need like antiparticles that don't normally exist in nature, then you have like a little cache of antiparticles you can use for stuff. Is that how you would do it, basically?
I think so, but the trick is that you have to keep the anti-whatevers. The trick is keeping those around, right? So if you have an antiparticle and a regular particle, and they collide, then they annihilate each other, and you get a bunch of energy, and then you have no
you
particles.
Can do that. You can do that pretty easily, right? Because they would have opposite charges. So that should be pretty easy. Well, easy, easy for them.
Well, I think, I mean, in theory, easy, but it looks like a lot of this guy's work is developing new ways to actually grab the antimatter.
To actually like trap them. I mean, that's what because protons are very stable, right? I mean, there's that whole debate as to whether a proton will ever decay, but I don't know how. I would assume that means an antiproton would also be stable if it was created, but of course I don't know, like in a collision, how likely you are to produce, like how likely a particle collision is to produce like an actual full-formed proton rather than like, I mean, I know you get a lot of quarks and antiquarks, but I don't know how likely those are to like coalesce into a full antiproton.
You got me. Yeah, it looks like it's pretty tricky. So they have a paper from June of 2011, where they successfully held on to antihydrogen for 1,000 seconds, which is what, like a little more than 15 minutes.
Yeah, something like that.
Yeah, so that must be pretty hard if that gets you a Nature paper.
Okay. Well, so that tells us something about the state of the art, I guess. But
there's a diagram of how they do it.
It's finally at the end of the article. Antihydrogen did not behave weirdly.
Ooh, the mechanism has the excitingly named annihilation detector, an octopole, and a mirror.
Oh. Okay.
Oh, it's a mirror coil. I don't even know what that means.
I don't know what that means either.
But I kind of want to buy an annihilation detector.
So this is it sounds like the confidence intervals are pretty
large
here still. So it says antihydrogen did not behave weirdly, so they calculated that it cannot be more than 110 times heavier than hydrogen. And if it's anti-gravity, and they can't rule that out yet, it doesn't accelerate upward with more than 65 Gs. So it sounds like the confidence intervals...
Wait, so I found the interval. It is... they can rule out ratios above 75 and below minus 65.
Okay, that's almost what it says here. I don't know where they got 100.
Oh, so 110 is if you include worst-case systematic effects.
Oh, okay.
So I think the physicists do a lot of this, where they try to model like how their instruments could be screwed up, and then they bolt that onto their like experimental error.
Right, but that, I mean, so if you take what is it, negative 65 and 75, that means what they actually measured was like, well, I guess actually, it should be what they should measure is 1, right?
Well,
like plus 1.
The next sentence is, obviously, our limits are far from the F equals 1 regime, where one could test for small deviations from the weak equivalence principle.
Yeah. Okay, so this is really like a proof of concept that it could be measured more precisely.
Right, so they need to get it goes on, it says if we could get the atoms colder, maybe with lasers, they want to get them to below 30 millikelvin, which is absolutely freezing.
Yeah.
And then stronger magnetic fields, they could measure gravity around around 1. So our ratio is around 1. So
stay tuned.
Give them lots of money and stay tuned, yeah.
Okay. All right, so that was kind of technical, but that could be good, I guess, for podcastery.
It is kind of funny to look at the stats, because they're like crazy physics stats, and then all of a sudden it's just a chaos test.
Yeah, which is a Kolmogorov-Smirnov test, right?
That's why I never say its full name, because I'm not entirely sure how to pronounce it.
Then you have to go da at the end.
The test is to find the maximum.
It is a good test.
It is not a good
much
test.
Much better than the capitalist test that
good,
you all use.
or not nicht good.
Do you think non-parametric tests are just the communist version of parametric tests?
In Soviet Russia, statistics tests you.
Soviet Russia. Yes, assumptions make you.
I will be saving that for lab meeting.
All right, so a little stats humor there. Okay, so basically, antimatter may or may not obey the law of gravity or the law of anti-gravity, so stay tuned. But that seems, I wish I could find this thing that I was looking up the other day, because this got into, because this plays into, this seems relatively important, I would think, to this other thing about dark matter, right, and dark energy and so forth, and the possible detection of a dark matter particle, right? Because, well, I don't know. I guess it really depends, right? Because, we have this problem with dark matter where, like, gravitationally it appears that there's much more matter in the universe than we can observe, right? But I guess if antimatter, what little there is in the universe, or is thought to be in the universe, actually behaved with anti-gravity, that would make the problem worse, not better, right?
Well, it depends on the ratio, right? So you could imagine that there's way more dark matter and it all behaves the same. Or maybe the dark matter and the anti-gravity
but like I was talking about like antimatter and anti-gravity, right? So if, whatever antimatter there was in the universe, if it had anti-gravity, that would really just make the dark matter problem worse than we think it is, right?
Well, it depends on the ratio, right?
Because it'd be working against the regular matter gravity.
Yep, if it's, yeah, I think so.
But, that said, the ratio of actual antimatter in the universe is thought to be pretty small, right? So,
I thought it was close to 1-to-1, but I have...
What? No, that's one of the big questions, right?
Yeah, but I thought... Wait, how do we know this? From the acceleration of stars and stuff, right? They're moving too fast for all the matter that we can see. Is that how it goes? Wait, ignore me. I'm confusing dark matter and antimatter.
Wait, are we talking about dark matter, or are we talking about matter-antimatter asymmetry?
Yeah, I was mixing those two up in my head. Ignore everything I just said.
Oh, that's all right. We can cut this all out. Well, clearly we're not physicists anyway, but maybe what we say might, probe someone to want to learn about physics. I don't know. Or just make stupid jokes about physics. But so it only kind of relates. But I guess it is true that, like, there's not thought to be that much antimatter in the universe anyway. So I guess it isn't thought to significantly affect the other problem, which we talked about, which was the dark matter, the possible discovery of a dark matter particle, which is kind of interesting. Although it's only at the 3 sigma level, so only like 10 times more scientifically rigorous than most of our experiments.
No, 3 sigma's only...
Well, it's only 1 sigma more, but...
It's 0.01, right? 0.001.
It would be 99.8% chance, so... Yeah, I don't know if that's one-tailed or two-tailed. I'd have to remind myself. But yeah, like, so, if we normally take a 5%, so that would be what? Well, 25 times more confident than we are.
Yeah, well, to be fair, if, I could collide thousands of monkeys at high speed, I could...
And it would produce the works of Shakespeare.
That's the dream.
Yeah, so, well, I guess we don't probably want to get into the WIMP signal, the weakly interacting massive particle question, too much. But I will have to, maybe at some point later I'll look up this other theory about how, like, if you tweak the laws of physics a little bit over time, you can, like, get rid of a lot of these annoying things, like why there isn't the same amount of matter and antimatter in the universe, and because I'm not sure how deeply those are connected, in the standard model, right? Like the matter-antimatter balance and the dark matter phenomenon.
Yeah, no, I have no idea.
Okay. Anyway, all right, well...
As an aside, I have standard model envy.
How so?
Don't you wish we had like a standard model of the brain that we could test things against?
Yeah, I mean, well, yes.
I mean, they have the whole universe, and they can, more or less describe it with a handful of equations. I have like a 2 millimeter by 2 millimeter square of tissue, and I have no idea what it does.
You're talking about your penis, right?
Ooh.
Well, this is another thing that I remember from The God Particle, an excellent book written by a Nobel Prize winner. But he talks about like the dream being like a model of physics that can fit on a T-shirt, and at least in 1992, he said, well, basically it fits on a T-shirt if it's really big and the print's kind of small, So, but obviously, what you'd like is like about 5 equations that or one to rule them all. But yeah, I mean, but it's a different thing, right? Because obviously the brain is a complex system, so you're not going to have any like.
But the brain is a proper subset of the universe. I mean.
Right, but I mean, in other words, when you're describing the most fundamental things, they're going to have the most fundamental behaviors. I mean, you're really getting into more like, network dynamics and complexity theory and things like that if you want to have like laws that describe the brain, but. Then you're always talking about approximating like large scale chaotic patterns, right?
Yeah, I'd be okay with that.
Well, I mean, there are people trying to apply those things, but like, I don't know. It's always been a little bit unsatisfying for me, right? When you look at these people doing like the large, not naming any names, but when you talk about like the Connectome projects.
Oh no, let's name some names. Yeah, all of that is sort of. Well, I mean, we'll see.
But They do papers where they're like, well, what we've proven is that the brain is a small world network, which basically means like, you can get from neuron A to neuron B anywhere in the brain in like a relatively short number of connections, which, I mean, we kind of already knew, right? We just hadn't mathematically.
I have actually seen an even worse paper where they argue that the brain is not randomly connected, which, yes, you can tell by looking at it.
Like the dendrites don't just spout off in any random direction?
Yep.
Yeah. Seemed to be, I mean,
cracking work, guys.
Assume a spherical cow. I mean, you do have to, like, I guess, show that, but then you would like to, yes, you would like to refine your theory to the point where it vaguely approximates things we know just by looking. But I don't know. Right, but all those theories seem to be like, so we've proven that all the stuff in the brain is connected to each other. So I don't think it's gotten much more sophisticated than that, obviously.
No, although we'll see with this like $1 billion getting poured into it.
Yeah, I would like to get. Is there like a form I can fill out to get a piece of that, or do I have to show like a driver's license, or?
I think you just stop by the White House with like a. You have to bring your own bag, though. They charge you a nickel if you don't have a bag.
Oh, okay, that's good. They've actually started doing that in the equatorial country. Do they do that in Canada too?
Yeah, they do it in the U.S. now, too.
Oh, do they do it in a lot of... I mean, it makes sense, but what's weird is they do it only on Saturdays here. This is a bit of an aside. Have I told you this before?
No, that's actually kind of strange. They only charge you for a bag on Saturdays.
Well, I think it's a thing, like, A, because Saturday's a big shopping day, right? And B, because it's trying to, like, ease people in without them thinking it's completely tyrannical, to only have, like, one day a week. But the funny thing is, I think a lot of people don't understand... They don't think about the logic of it, right? So, like, when I come somewhere with my canvas shopping bags on Saturday, they like have no problem with it because they're like, okay, yeah, you want to save like 10 cents a bag. But when I bring them on other days of the week, they look at me funny. They're like, but it's not Saturday. You don't have to pay any extra for a plastic bag today. And I'm like, but it's still good for the earth all of the days, right?
That's actually kind of surprising.
Yeah, I mean, I'm exaggerating a bit, but it is true that like people. They don't do it just for the sake of, like doing it because to not waste material. They really do it just because of the economic incentive. And they don't seem to understand that like it might be good to do other days of the week even without the economic incentive.
Huh. It's funny because the opposite sort of works for me. Like I have spent way more than 5 cents of my time to walk back home to get a shopping bag.
Oh, yeah. Well, I mean... And what's funny is actually, like, I was very bad when I was living in the States about, like, I had canvas bags, but I would never remember to, bring them with me or anything. But here, because people are so, like there's no recycling anywhere, really. I mean, on the university campus, we can recycle stuff, but like at home, I have no options to recycle, so I just have to throw everything out. But like because people are so sort of like willfully non-recycly, I have decided to do it just out of sheer contrariness. I'm like, all right, well, screw you guys. I'm bringing canvas bags everywhere I go.
So DC implemented this, like, I don't know, probably right after I moved out of there. But it was weirdly successful. So they charge 5 cents a bag, and I can't remember how it goes. Either 4 cents goes to cleaning up the Anacostia River, which was kind of a polluted mess, and 1 cent goes to the city other way around. And like a couple years after it went into effect, I think they were using, 90% fewer plastic bags. And the river looks like... Cool. I mean, I wouldn't go for a swim yet, but it doesn't look like a floating garbage dump like it used to.
That's good. I mean, now you have to keep in mind that DC is entirely peopled by like, poor urbanites and incredibly hippie, liberals who just graduated from college and like to protest things.
Zing!
So
how?
Well, it's
take it on the nose here.
Well, no offense, former DC resident, but no, I mean, but it is true, right? I mean, like everyone in DC it's not hippie-ish in the way that like Portland is, but it's very like left-leaning, right? Yeah. Well, so I was just looking up the presidential for various reasons that are unrelated to anything. I was looking up all the presidential elections.
Oh, DC always goes Democratic, like by like 90.
Even in the cases where like the Democratic candidate, like, who was the one? Now I'm going to quickly run through.
Marion Barry? Is that where this is going?
No. Although, I mean, he is a fantastic example of how people in D.C., who you would think would be very good at politics and figuring that out, not so much. Let's see, where is...
For people who don't know the backstory here, Marion Barry was the mayor. He was then arrested in an FBI sting for... actually a whole bunch of things, and ranging from drugs to, I think there was some corruption in there too. And there's a fairly famous video of him taken by the FBI shouting, "The bitch set me up, the bitch set me up," as he runs around in a hotel room, I think with cocaine. So yeah, he went to jail, got out of jail, and then ran for city council and was reelected. And then I think he is in legal trouble again over taxes, although that may have been sorted out by now.
Yeah.
But yeah, so he's... DC's city council for life at this point, I think.
Yes. Well, I mean, he still beats former mayor of what was Jerry Springer, the mayor of Cleveland?
Yes. Don't pay for strippers
or Cincinnati.
With city checks.
Cincinnati, I believe.
Yeah, it was one of those.
Don't pay for your prostitutes with checks, kids.
I think she was only a stripper.
Was that true? I thought it was. Well, either way.
I met him once. He's actually a surprisingly smart man, except for that.
Oh yeah, I think he's supposed to have like a genius level IQ, if I recall correctly. Just not with regards to payments of prostitutional humans. Okay, so if you look at the U.S. presidential elections from 1972 and 1984, so 72 was Nixon-McGovern. McGovern carried, I believe, yes, one state plus the District of Columbia. He carried Massachusetts and Columbia.
Of course.
Sorry, District of Columbia, yeah. Massachusetts and D.C., yeah. Not the country of Columbia. And in 1984, Ronald Reagan won every state but Minnesota, which was Walter Mondale's home state, and D.C. So in the two presidential elections in recent history, we're like, first of all, I didn't realize that did you realize that Richard Nixon won in 1972 with 520 to 17 electoral votes?
Yeah, I knew it was a landslide. I didn't realize it was quite that big of a landslide.
I did not realize that Nixon won with that great of a landslide. Yeah, it's kind of insane, but yet still only like 60% to 37%. But basically, I was looking to see like what the widest percentage in the popular vote swing was in the U.S. in recent history. And that's about as wide as it gets if you don't count like. I also didn't realize I had forgotten how much Ross Perot screwed up like the 1992 election. Not screwed up, I guess, but like threw off the.
Well, yeah, he was a big spoiler.
Yeah, I mean, well, I think it's fairly clear that he took a lot of Bush votes away. Like, I think Clinton, is thought to be likely to have won either way, right? But I mean, Ross Perot got 18.9% of the vote in 1992, which is
Really?
yeah, exactly, like way more than I thought any third-party candidate had gotten in recent years.
As a child, I just remember being annoyed because he had his like special presentations on TV where he would stand there with like a big pie chart. He would talk about the economy.
Right, yeah.
And that cut into like cartoons or 3-2-1 Contact or something, and I hated him for it.
Which is funny because nowadays you would probably be like, ooh, graphs.
It's
I
true.
like this candidate the best.
Be like, get this educational crap off the air. I want to see some graphs.
If only Ross Perot had PowerPoint and Venn diagrams back in the day.
He may have had Venn diagrams.
He might have had Venn diagrams. Yeah.
I also remember I made a Ross Perot puppet. We had to make like a political cartoon or something.
Was it named James Stockdale?
No, but I made an elephant with this
a puppet of Ross
with this
Perot.
like really expensive paper that the art room had like one sample piece of.
Yeah.
And I talked about how it was like some kind of satire. I was a weird child. Probably a weird adult.
And just by doing that, you were the greatest political cartoonist ever.
It's true. It made more sense than most of them.
Yes. It's a snake-eating democracy.
Hey, don't tread on me, man.
But the don't tread on me snake is eating his own tail. So you see... Actually, I don't know what that represents.
It's an Oberos or something.
Which means... Doesn't it mean... Oh, no, that's something different. What's the word for belly button in Greek? It's a great word, and it's in Ulysses. Oh, maybe it is. Omphalos. That's a different word. Anyway, there's a whole bit about the omphalos in Ulysses, if I remember correctly, but that's getting a bit off topic. But anyway, yeah, so DC, super, like, liberal to the point of, like, voting for the Democrats, even when clearly it's a lost cause. In the case of Mondale and the other guy whose name I just blanked on. McGovern.
Well, I mean, you don't get to vote for Congress. Might as well vote for something.
Yeah, but anyway, what are we talking about? Oh, right, DC, plastic hippies. The other weird thing about Malaysia, and then we'll go back to science, I guess, is that the word plastic now means plastic bag. Like, they'll just ask you if you want a plastic, which is bothersome to me.
Up here it's sack. Everything is a sack.
Oh, really?
Which is confusing in the state-run liquor store, which is also called sack.
Is that State Alcohol Commission or something like that?
It's in French. It's like Société Alcoolique du Québec.
SAQ.
Yeah, it's SAQ. But I don't really speak French, so when the woman says blah, 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 sack, I'm just like, oui, sure.
Is sack French for sack?
No, that's not in English, too.
Oh, okay. But that's not the word in French.
I don't know. The French here is a strange mixture of, like...
Google Translate will tell me. Oh, no. Oh, yeah, that's right. I should know this. SAC, like SAC. Just lacks the K.
Huh.
Yeah. So we must have gotten that from... I'm assuming we got that from when the Normans, invaded England or whatever. It was the Normans, right?
Yeah. Do you think the Normans had to pay a nickel? Or a shilling, I guess?
I'm not sure. By the way, did you hear this recently? I don't know how true this is. The theory that the reason that Scandinavians are so good looking is because the Vikings basically like raped and murdered all of the... Well, they raped and murdered everyone, but they took the good looking women back with them.
I also read that was not true.
Oh, is that not really true?
But that would be an awesome story if it were.
Yeah, that's too bad. All right. There was an actual like historical confirmation of that.
Well, I also read this. I assume you saw that on Reddit, where I also read the debunking on Reddit. I think that there's not like the right genomic markers for that to actually be true, but I can try to find that.
Yeah, we probably don't want to get too deep into it, but
I don't know. It would be kind of awesome.
I mean, yes, it would explain a lot. Although, yeah, I think I'm assuming standards of beauty might have been slightly different back then anyway.
Well, it's true. Like, have you been to an art museum lately? Like, the beautiful women are all, by sort of modern standards, like grossly overweight and pasty.
Yeah. I go back and forth, right? I mean, I wonder if that was just the style back then, though, that like people didn't want to paint. Well, actually, I mean, I don't know. Like, I also feel this way about people in old photographs, right? Like, it seemed like everyone was pretty ugly before about 1960. Would you agree with this when you see any like historical photographs? Like it's very rare that you see somebody hot in a photograph from the 20s, even if they were supposed to have been hot.
Well, yeah, I mean, there's different cultural stuff, but I think, there's a lot to be said for having enough food to eat all the time and not having polio and all that.
Yeah, it's just hard to tell, I think, like how much is, genetics, how much is like good grooming, how much is changing societal standards, and how much is like, just poor photography. And, people looked grim because they were, they had lots of, illnesses or whatever.
Yeah, they were down to their last potato and,
Right, exactly. I mean, I guess with photography it's a little bit different, but, I guess I feel like maybe it's just because I'm a dude and I'm more attuned to what women look like. I mean, dudes from the 20s kind of still look like dudes now to me, but...
Yeah, I'd agree with that.
Yeah, but I think, maybe it is just that they, like, did their hair differently, and it's hard to tell. I don't know.
No, but I remember reading something... Maybe it was for history class, where this woman was praised for her plumpness and, like, white skin. And, you'd be hard-pressed to sell someone on how they should plump themselves up for the purposes of beauty.
That's certainly true, although, like, what you hear is, there's the whole thing about the the waist-hip ratio of 0.7, right? So even if, like, cultural attitudes favor, plumper or less plump women, people still prefer a waist-hip ratio of 0.7. So I think there are some universals, and I mean, I don't know. I've seen debates that go both ways on this, but I obviously don't remember them all off the top of my head.
I don't know.
On the other hand, if you look at like the ancient Greek statues, right? Like if you look at Venus de Milo, at least body-wise, she was very classically proportioned, or what I would call classically proportioned, meaning proportioned like people we think are attractive now.
Oh, about those statues. Did you know that they were originally painted?
I did know that. Yeah, that's a cool... you've seen the recreations, I assume, then, of like what they looked like when they were painted, right?
Well, so when I went to Austria, I guess someone at the... I don't remember the name. The Historical Art Museum was the person who had like discovered this. They look awful painted. They look like something that like...
they look terrible.
They're like garish and cartoony, and it's so different from the sort of like beautiful marble statue that everyone sort of associates with Greece and Rome.
Yeah. Yes. If we're still doing this for the podcast listeners and not just our own amusement, obviously you can't look at things. But oh wow, this one's really terrible. If you just Google like painted Greek statues or something like that, like this is a Gizmodo article from 2010, which is I think when we saw this the first time, and like the painting of the guy, the archer statue is the top thing, and yeah, he looks like a piece of Easter candy or something like that. He does not look like these elegant white marble statues.
That's a great way of describing it, actually.
I mean, it looks like sort of looks like Johnny Ive needed to get a hold of these statues and just like sand them all down so they only had one button.
I'm trying to find it at the it's the Kunsthistorisches Museum in Vienna. They had like a whole gallery of it was actually kind of cool. They had a statue, and then they had like a model of the statue where they had painted it with sort of historically appropriate paints and all that.
Well, that's cool. And did they really look as bad as...
They all looked awful.
Really? I see. I mean, I wonder like how... What I don't know is like what the limit of the technology is. Like, is it possible that they were better painters than the ultraviolet? Because the ultraviolet would probably only reveal like the base coat, right?
I think...
Because I mean, obviously, like they could have also had layers, and like an actual painting, that the base coat would be like the roughest layer, right?
Yeah, but they could get like very fine details down. So I assume that includes.
Okay.
I mean, those presumably, if it was painted in layers, the details would be on top.
Yeah, I don't know. I think we should we should change the title of this show to Rampant Speculation About Science We Don't Really Understand.
I thought that was the title.
Oh, maybe it is now. Well, it's the first episode, so we can decide at the end, I guess.
Well, we could come back and revisit this with, actual knowledge.
Yeah, we could revisit some of these topics. If anyone ever actually listens, maybe we can get some experts on that know these things that can answer our questions. For right now, we can just be an index of all the random science articles we've read over the last decade.
Hey, I went to an actual museum and saw this.
That's true.
Nelly paid, €10 for me to learn about this.
Well, that's good. But did you interrogate them about the science, or did you just, assume it worked?
No, they had a pretty big exhibit on like how it worked and, sort of the history of it.
All right. Well, yeah, I would be very interested to hear how it works. It would just be very sad to me if these statues were as garish as our recreations are, because they really don't look like they'd be worth saving the way that they look in the recreations,
Yeah, I also wonder, when the paint disappeared.
And, which body parts it disappeared off most quickly. Anyway, got to rub it for good luck. You've seen that statue, I assume, on the Yale Old Campus, and I think they've got a similar one at Harvard. Isn't there a John Harvard body part you're supposed to rub for good luck too?
Yeah, there's John Harvard. The one at Georgetown, we sat on his lap, so...
Okay. I
nearly got arrested doing that my last night of school.
Oh, nice.
Well, the cops come by and they're like, knock it off. I'm like, come on. Then they're like, all right, make it quick. They really should just put like a milk crate there and be like, all right, you want me to take the picture? Next.
Yes. Yeah, the one at Yale of Timothy Dwight, his foot is visibly... Well, I guess really I think it's a bronze statue, right? So it's just that the foot lacks a patina, whereas the rest of it has a patina. Maybe it's a copper. I don't think it would be copper. I guess it would be bronze.
Well, isn't there copper in bronze? No, that's brass.
I can never remember. But anyway.
One of those has copper and something else in it. Yeah, bronze is copper and tin. Brass is copper and zinc.
Well, so we could probably find out. So yeah, the Timothy Dwight statue at Yale.
Did people always rub him?
I assume you mean the statue?
Well, I assume they didn't unveil the statue and then everyone was like, yeah, I gotta rub that thing.
See, actually, he was the president of Yale College from 1846 through 1871, and the students used to rub his actual foot for good luck. And
that's actually much weirder than rubbing the statue.
Yes, I know. No, they did not actually rub Theodore Dwight Woolsey.
No, it's Timothy Dwight, isn't it?
Oh, wait, no, Timothy Dwight is someone else. Sorry, I got this mixed up. This is the statue of... So there's Timothy Dwight, but actually there's Theodore Dwight Woolsey, who is of the Woolsey things at Yale.
But Timothy Dwight is the one whose foot you rub.
I thought so too, but apparently on Wikipedia, which is always right, it says, yeah, the statue in Woolsey. Maybe it is the statue of Woolsey that has the golden toe. I should probably know this, having been at Yale for a decade of my life. But
yeah, this is kind of embarrassing. Cut this part out.
Anyway, it doesn't say what the statue is actually made out of, but I think it probably is.
I think
bronze. You wouldn't normally make a brass statue though, but bronze you would, and I think bronze does get that greenish gray patina, right?
Yeah, I think bronze.
The greenish would come from the copper oxide, I would think. I don't know. Anyway, but he definitely has a golden toe.
Wait, so seriously, did people actually rub his foot for good luck?
Yeah, well, I think people still...
No, his actual foot when he was alive.
Oh, no, that was me making a ha-ha.
I don't know, Yale's weird. I would buy it.
They would wear an onion on their belt, as was the fashion at the time.
You'd say, give me 5 Bs for a quarter. 4 Bs?
But I think it's 5 Bs for a quarter.
That is, in fact, the top Google autocomplete for 5 Bs.
Nice. Well, that makes sense. But, nowadays, of course, I don't think anyone, rubs statues for good luck that's an actual undergrad. So I don't know when it, when it's one of those things that, like the Blarney Stone, when it transformed from being an actual tradition to a tradition that is only performed by dumb tourists, so...
Wait, you didn't go rub his foot on, graduation or something?
No.
No.
That was not one of the things we do. I did break a pipe.
What kind of pipe?
Not that kind of pipe. No, the old... did you know this, that they do this at Yale? Yeah, you're supposed to break your... the legend was, back when everyone smoked a pipe, that you should break your pipe at graduation because now you're graduated and, you have to live in the adult world and get a job, and you don't have time to just hang around smoking your pipe all the time, which actually does kind of work for modern times.
I don't know. I sort of associate pipe
Different
smoking
pipe
with
contents.
old men.
What's that? Well, yeah.
Oh, yeah, that kind of pipe, yes. Maybe you should be breaking.
Well, I mean, but back in the day, it was a tobacco pipe. But the analogy kind of still works for today, right?
It also sort of sounds like you're being kicked out of Hogwarts.
A little bit, yeah. But anyway, so like you would ceremonially like break your, step on your pipe, kind of like a combination of, I don't know, like old white British men and like a Jewish wedding. But
so do I have to go buy a pipe for next week?
Well, are you're officially graduating next week, aren't you?
I'm picking up
the
receipt.
Are you going down to walk, or are you
my mother would not have it neither way.
Oh, really? Because, I mean, obviously I was in Malaysia at the time.
Give me 3 ringgits for a quarter.
Yes. I don't know if they do it for grad school, but for undergrad, like does the Owl Shop still exist? I think it does.
Oh, the Owl Shop is more popular than ever.
Oh, that's right. Now that it became the Owl Shop with booze. But they would like give everyone like a kind of cheap clay pipe and a little tobacco packet, just enough to smoke once, so that you could like smoke your pipe once and then break it. I still have the pipe pieces somewhere. My original undergrad diploma smells like tobacco, actually, because like I packed them all up together. So it kind of smells like it's been in someone's study with their rich leather-bound books for.
I was gonna say, I feel like a Yale diploma should smell like tobacco and leather and shoe polish, maybe.
I should put like an old leather jacket in there, and a map of the world, when it was flat and so forth, and get all the smells just right.
Can you write "There be dragons" over Cambridge?
Why not? But anyway, so I would just like to. So we've kind of danced around the A Boy and His Atom video, but we could mention that. I suppose it's cool. It's once again something we don't know how it works.
Although there is a handy companion video, which neither of us has bothered to watch.
Well, is that the? So I was just mainly going to say that I'm very amused by the thing that shows up on YouTube on the sidebar. This was made by IBM. This movie where they're manipulating individual atoms and then making the movie with. I guess this is an electron microscope image. But on the side, they've got another film by IBM that's only 1 minute long that's called IBM Atomic Shorts, which I assume what they mean is short films made with atoms, but it does kind of sound like, radioactive under things.
I would...
Oh, wait, sorry. The subtitle is Ripples on the Surface. Krause, you've got ripples on the surface of your atomic shorts again.
Yeah, so I just found the IBM page. So they're using a scanning electron microscope, scanning tunneling microscope.
Oh, okay.
And they can drag individual atoms across. They sort of dumb it down here. They said they're using it like a needle to drag atoms across the surface of a piece of copper. And then they're actually carbon monoxide molecules on top. And then if you go to their...
Wait, what are the atoms, though? They're just atoms of... I'm confused. Say again?
Carbon monoxide, I guess, is stacked. So it's carbon monoxide, and then it's just carbon and oxygen. So you're only seeing one atom, but they're like 2 atoms tall.
Oh, okay. Oh, I see what you're saying. Okay, so for some... whatever interaction the carbon monoxide... molecules have with the copper, it causes them to kind of stand on end on top of the copper.
I guess.
And then you're looking at them from above.
Yep. Oh, so those ripples around it are actually changes in electron density. That's kind of crazy.
That's cool. Am I imagining it, or does it look like there's? I would have thought they would be kind of spherical, but they almost look hexagonal. Or is that just my imagination?
I'm zoomed way in, and they look pretty spherical. They're in a hexagonal shape.
Okay, it looked like there were some lines to them, but I could be imagining. Although,
I guess it's just from the packing where they make like the boy's head. I mean, that's definitely on a hexagonal lattice.
I was looking at the patterns around and the individual one on the title screen, but let's see. I swear there's some non-sphericality to it, but anyway, or maybe it's an octagon, but I could also be making it up.
I'm trying to think. Could it be...
Well, I was trying to think if it had to do with, the
bond
fact that
angle?
they're like... Oh, I was thinking the like eight. I mean, the electrons occupy positions where where the radius, where the circumference like divides evenly into their wavelength, right?
Yeah, in the shells.
Yeah. So could it be some? Well, then again, I don't know. I mean, I don't know enough about how the microscope works to know if that could have something to do with that. But which I'm assuming. Do you much about scanning tunneling microscopes?
Not at all. We can talk about that next
All
time.
right. This would be another thing to ask one of our friends who uses. I mean, because I've never. I should just look it up because I'm sure Wikipedia would be enough to tell me. It's never really made sense to me why you can get better images from an electron microscope than a light microscope, given that light is smaller than electrons. But I'm sure there's some dumb reason that I'm not thinking about.
Oh, wavelength.
Oh, I guess the wavelength.
You're limited by the wavelength
Of
light. Right? Right. So light has a wavelength of, I don't know, depending on what color, 500 nanometers.
Yeah.
So that means you can only see things that are half a micron across.
Well, is it just that we can only generate? I mean, we can generate light of any wavelength, right?
Yeah, I guess you could use an X-ray or something, but that might have other problems.
Well, that's what I don't know. Or maybe or do you just have to make the photons, or do they become so high energy that they impact, what they're hitting too much?
Well, high energy photon is just like an X-ray, right?
Yeah, an X-ray or gamma ray or whatever, right? But
yeah.
But I don't see why you couldn't have a gamma ray microscope.
I think imaging living things with... Well, you can't do living things with an EM either.
Yeah, so, I mean, again, I'm sure there's a good reason for this, but that we just we don't know. We'll cut out all the parts of the podcast that make us sound like we don't know what we're talking about, right?
Sure. We're actually having like a microscope fair in the room where I normally eat lunch. So I will ask them about this.
Okay.
And then I will ask them if they can move all their crap out of the way so I can eat lunch.
We are smart enough and educated enough to understand the explanation when it's given to us, but I've never bothered to look at it.
Okay. I can give you a quick explanation right now. So the original TEMs, the transmission ones, basically do exactly what you said. So they have a high voltage electron beam. I guess just because...
You're looking at the same Wikipedia article I'm looking at, aren't you?
Yeah.
Okay, but you're about a paragraph ahead of me, so go ahead.
Okay, so it does exactly what you suggested, except they're using electrons. Maybe because they're easier to generate, right? You're just using a cathode.
I mean, it is easy to make electrons, yeah, I'm just...
So people don't really do TEM too much.
Yeah, I mean, I always hear about scanning electron microscopes more than almost anything else. Or scanning... which I don't know what the difference is between that and a scanning tunneling microscope. Hope our obvious Googling is not too loud on the podcast.
Oh, I've been trying to type super quietly.
It's based on quantum tunneling, actually.
What?
Oh, okay, so a scanning tunneling microscope is actually totally different than an electron microscope. All right, then maybe we got to talk about microscopes on a future episode, because they look cool.
Okay.
Maybe we should just...
Yeah, we'll plan episode number 2 out better.
By the way, have you ever noticed this? I never realized this before. This is a random science fact that we can end on. And I guess it just never occurred to me till it was explained. Your iPhone or your iPad or whatever uses a capacitive touchscreen, right?
Yep.
Which basically means that there's, for the uninitiated, there's a charge basically behind the screen or behind the glass, right? And when you put your finger up to it, what's a good way to describe? Well, you are better at electrical engineering stuff than me. What's a good way to describe? Basically, the opposite charge to whatever is behind the glass gathers on your finger, right?
Yeah.
Is that a good way to put it? So in other words, what it's doing is it's basically, and then as you bring your finger closer to the screen, you're bringing the charge in your finger closer to the screen, and the screen can detect that, basically, right?
Yeah, basically you're a conductor, it's a conductor, and then you can see the change in capacitance.
Right, but the weird thing is you don't have to actually touch the screen for that to work, right? So the screen that you're touching is just glass. It doesn't have any sensor. Like, the glass you're touching is not detecting you touching. The capacitive touch screen is detecting when your finger is, basically when the charge on your finger is is high enough that it is about what you would measure from a finger as far away as the surface of the glass, right? You see what I'm saying? So it doesn't matter that you're touching the glass. It matters that you're, like, if the glass weren't there, but you could hold your finger very still where the glass used to be, the capacitive touchscreen would still work.
Oh, yeah, for sure. Yes.
Right. So have you ever noticed that? Like, since I've learned that, I've actually noticed that a few times with, like, my iPad, that if I go to tap, sometimes I don't quite tap, or at least not enough to sense it with my finger. Like, I just miss it by a little bit, but it still works. Have you ever actually observed that happening in real life?
No. Although I have played a ton of that stupid game you got me hooked on.
Which one? Was that Temple Run?
Yes. I hate you.
I couldn't remember if I had suggested that one to you. But it's weird. Like, once you know once you're attuned to that, like, every once in a while you'll notice that, like, you go to tap and it's the sort of, usually you aren't that precisely in control of your motor action. So, like, you actually hit the screen, right? But every once in a while, 1 out of 50 or 100 times, you, like, jerk your hand away too soon, right? So you actually stop like a millimeter short. But some of those times you will still create a tap even when you don't feel it, because you got your finger close enough to the screen that the screen thought it was a tap, even though you did not actually come in physical contact with the surface.
Whoa. Do you know where the original touchscreen is from? Bringing this all back around. It was in the control room of CERN.
The very first, like, actual touchscreen?
Uh-huh.
That's cool. Was there a particular reason they needed a touchscreen, or they just thought it was cool?
Sounds like they thought it was cool.
Yeah, I mean, that would make sense to me.
We have all this gear.
The people in Star Trek keep touching the screens, so I guess we should also do that. All right, well, that's enough rampant speculation about science for this episode, I guess, right?
Yes.
So we didn't have a rant or anything, but we can do that in a future episode.
Yeah, we've ranted about a few things.
Yeah, we have mini rants. All right, well, I've got, because we've got about an hour and 25 minutes of audio, which means we probably have about, 8 minutes of good stuff. So shall we say goodbye to the people?
We shall. See you next time.
All right, thanks for listening to the, are we calling it the Super Science Happy Hour?
Yes.
With Matt and Matt?
With Matt and Matt.
All right, so goodbye, people.
Adios. Whoa, you turned into a robot right at the creepiest part of that sentence.
Wait, what's that? Oh, you know what? This is what balls. I still sound like a robot, don't I?
No, it's you're back to normal.
Oh, really? Because you're still breaking up a bit.
Oh, you're breaking up now.
Talking. Okay, well, maybe I sound okay again. How about you?
Yeah, you're back to normal.
Okay, good. They said this, I don't know if you ever watched This Week on Tech or any of those shows, but they refer to that as siloning, and apparently if you're on a Skype call for about an hour, oftentimes you start siloning at right about the 1 hour mark, but it seems to have gone away, so maybe it's just
I think it's just a vocoder. I think it's just you run out of, maybe Skype has some memory leak or something.
Yeah, that could be. I mean, I think it's usually video for them, which is the bigger issue, but I've heard them remark many times that, like, for some reason, right around the 1 hour mark, you get some siloning. But I think if you just, I think it does resolve itself. But we are at the 1 hour and 4 minutes mark right now, so that would have been about right.
I can believe that Skype is a poorly written piece of
Yeah. I honestly have to say that I'm also, several versions behind, because I hear that it keeps getting worse with every version, so...
Me too. I'm lazy.
I'm in version 6.2, but I think it's up to
6.2.0.1117.
Whoa, that's me too.
Dude,
somehow we've got
friends.
the same Skype version down to the milliskype. I believe is the official metric for that.
Wait, so is 6 the Skype? That's the deci Skype, the centi Skype? Yes, the milliskype.
Actually, no, it would be a tenth of a milliskype, right?
Well,
0.1117 is 1,117.
You're right. So that's
milliskypes.
So that's right? A microscope.
Well, it would be.
Yeah.
No, wait. No, it would be 11,170 microskypes, right?
Oh yeah, 1117 or 1.1. Yeah. No, it's 1.1 microscopes.
You know. By the way, this is totally going to the podcast because I love the scope. You know, I think I posted this on Twitter, but maybe didn't tell you, is I wanted to have a cover band with 10 Fab Morvan and 10 Rob, whatever his name was, impersonators singing, Girl, You Know It's True. And the band, it would be called Senti Vanilli.
That's pretty good.
So intro music would occur. We can talk about that. Should just be our intro music.
Yeah,
it's called The Scientist.
It's called The Scientist. It's kind of mopey and Coldplay-ish.
How about if we played the Glee version of The Scientist, which apparently exists? Is that better or worse? Or
I'm trying to find the Skype button that will allow me to strangle you.
We'll cut all this out, as Merlin Mann always says. Wait, this just looks like Lyman through a weird looking glass. Is that what you're talking about?
Yeah, but they're eating Garfield.
What? No, it's just Lyman's face.
I sent you the wrong link.
Square face. I think you sent me the wrong one. This is some kind of weird pornography. I think you might have sent me what was on your clipboard before.
Zing.
That's not true.